Okay, you scan on the QR code to find out a bit more about how the chain splitter works that we're using for this CAD assignment. We'll try and draw one of these up in Onshape, but it's always best to know how it works and what it does before we start trying to disassemble it and do the drawings that we need to create. Okay, so this is the chain splitter, but what's its actual job? Well, its job, as its name suggests, is to split chain. So a chain on your bike is what transfers the motion from the crank where you pedal to the cassette at the back that turns the back wheel. We won't go into gear ratios just now, but that's a very useful part of your bike, okay? So now, this is a shorter length of chain that I've taken and rejoined together, so I haven't got a big amount of chain in front of me, and I've cleaned it up. I've taken off all the oil from there, right? This chain is worn out. It doesn't look worn out, but it is worn out, right? Let me tell you what's happened. Riding it through a few winters, the oil I put on the chain is mixed with the dirt and grit on the road, and it's formed a very fine paste that's quite abrasive, and it gets in between the links on the chain and it wears them out. Now, you don't notice it at first, but I have got a machine in the shed, or a device in the shed, which measures the length of the chain over a few lengths like that, and it's got a go no go guide, right? If it slips onto there and jams, then you know the chain's okay. If it moves over it, you know the chain has actually stretched. So this one here is worn out, right? So it's no good. So I brought it into school to show you how it works. Now, so let's have a look. That chain normally is in a complete loop, and if you want to take a chain apart, either to change it or to lubricate it and clean it more easily, then normally your best way is to look for what's called the split link. So the split link on your chain is designed to fit together with this slot. So the link on the chain drops into the, if I can show it more easily, the larger hole on the slot, and then same with the other side of it, and then when you pull them together they snap close together. So one side is joined to that part of the chain, the other is to that side of the chain. As soon as you start pedaling, it pulls that link together and locks it in place. Now, taking a snap link apart when it's snapped shut is actually it requires quite a bit of effort. So what you can do is you can bend that chain where the split link is, and you can try and pinch it as hard as you can together with your fingers, and you can split the split link apart. If not, you have to get a very thin pair of long nose pliers and pinch that together with the pliers, and you can split your chain. You can get a special tool for doing it, but those are all tricks for taking split links apart. Now, we're not really dealing with split links, and I'll put that chain to one side a minute as well. We're going to deal with how to split a chain using a chain link splitter. But one last thing before I get there. Okay, look, let's look a bit more closely about what the component parts of the chain are there. So each separate part of the chain is called a link. So you might have heard of a link in a chain, okay? So each separate link is made up of several parts, okay? You've got the outer plates to the hinge, and you've got inner plates to the hinge as well, which is a smaller version. So that's the pieces that you can see inside here, okay? So you've got inner and outer plates, and then what you've got is you've got a pin that is driven in the holes in each one of those plates with friction, okay? So that's what we call a transition fit, an interference fit. So you have to force that pin in, and it stays in place because it's a tight fit. And that pin then traps in place a little roller, and the roller is designed to rotate very freely in between the pin plates, and that reduces friction in your chain system. Okay, so there's the separate parts. That's what's in each part, each link of the chain. Now let's have a closer look about how we can split it. So there's a really handy little piece of tool here. I mean, it's quite hefty. It's probably not the sort of thing you'd want to take on a cycle ride. So, you know, if you've got a multi-tool, they're much lighter than these. This is made out of steel, all right? It's probably tool steel, so fairly high carbon content steel. Part of it's been made on the lathe. This is called a knurl, this grip pattern that's been put on. And also this kind of fillet, external fillet that's been put on the lathe. And it's been fitted into, probably with a screw thread on the end of here, into a bit of hexagonal bar. Right, now it's got two component parts to it, okay? The black bit doesn't come apart, but this piece does come out, all right? Now, so that's the body of the chain splitter, which we're going to be drawing up in CAD. And the body of the chain splitter has got a threaded insert. I think that's M8, this thread, okay? So that means that that bar is 8 millimeters diameter. So that's an M8 thread. It goes through, so it's a through hole, so it's threaded right the way through, and then it goes into this section here, which is designed to hold the chain as it's being split, which sort of sits in here. I call it kind of the anvil, but I don't know what its actual proper name is. So these plates are for aligning the chain after you put it together, and this thick, strong plate at the back is for pushing the chain out, the link out. So this part, then the silvery part, is threaded, like I say, with M8 thread. I think it's M8 times 0.6 pitch. So that means that each of those ridges is 0.6 millimeters apart. Now that gives us pretty good transition of force, okay? The distance between the threads changes the amount of force that you can transmit through the system. So that rotational force, that torque, that torsion is transverted to linear motion, and the force is amplified through the pitch of the thread. The other thing that amplifies the force is the length of this bar here, which we call a Tommy bar. The longer the bar, the more leverage you get. So as you turn that round, let's have a look at it. Let's think probably 2 full turns moves that about 1 millimeter. So, you know, that's a good force system, that is, right? Okay, how do we actually split the chain? Well, I've put one that I've already started there. It's a bit easier to do. You drop your chain where you want to split it over the thicker part there. You line up the pin, and as you drive the pin out, you will feel the friction suddenly decrease as you get outside, so that the pin is only trapped by the outside plate. And what you should do then really is pull a chain apart like that and try and leave that pin in the outer plate. It makes it much easier when you come to try and put the chain back together. So that's using the chain splitter to take a link out of a chain. So this is what we're going to be drawing, okay? All your dimensions you need are in the guide that I've given you, and you can scan the other QR code that's on display to find out a bit more about how you actually draw it up in Onshape.